Alright class, so today we're going to talk about 6.2 normal distribution applications. So now we're going to talk about, well, what if we're given the applications of what we do for normal distribution? So all the stuff we did in last section of 6.1, right? We were able to find areas. Now how are we going to associate that using our portion here? Okay. So back in the day, right, there was one very special rule we talked about with a normal distribution, and that was the empirical rule. But that only gave us 1, 2, and 3 the whole numbers, right? And we found out that z-scores can be also decimals. So the question now becomes, well, what if we do not have a mean of 0 and a standard deviation of 0? For instance, what if our mean is 68 or 72? How do we find, the area underneath the curve by that standards? Because, that's not a z-score, right? That's z-scores are, on the number line between, roughly negative 3.5 to positive 3.5, right? So the thing we want to talk about now is, well, we have to convert it to its standard normal distribution, meaning we have to convert a value to its associated z-score. And how we're going to do that is using this equation here. Okay. So this is mu, right? So this is the mean. This is sigma, so that's standard deviation. And x is the value we're converting itself. Okay. So let me give you an example how we can do this using the associative. So here we have a list of stuff, and it actually goes to the other page soon. I got a little cutoff from mine. Okay. So the question A is just ask you to find the mean standard deviation, and I will give you that because I'm not going to make you guys actually find mean and standard deviation yourself. Okay. So now what we want to do is we want to convert all of these values, these heights of women, to the appropriate z-score. Now these are the x values associated, right? These want to convert and given this mean and standard deviation. So we're going to do the first two for practice. Okay. So the first one is x is 55.9 minus the mean, which is 64, divided by the standard deviation. Gives you that. So remember order operations, you first subtract first, then divide. So if you do that, you should get negative 1.39. Okay. So now let's try the next one. So z is 58.6 minus 64 over 5.83. So again, subtracting first, then you divide, should give you again negative 0.93. Okay. So at this point, why don't you guys pause the videos and try the rest of it. So the ones on the back, and also try part B here. Okay. So 3, 2, 1, pause. Okay. So hopefully you guys tried them. So I'm just going to give us the answers here. So hopefully you guys got negative 0.46, 0 for this one, 0.46 here, positive, positive 0.93, and then finally 1.39 for those. Okay. And now for B, right, gives a little trick question. Is this how many standard deviations above or below the mean is a height of 68 inches? Now remember, if you're not sure what this means, remember, going back to the definition of a z-score, that's exactly what a z-score tells you, right? How many standard deviations above or below the value actually is. So what they're asking you is just simply find the z-score first. So 68 minus 64 divided by 5.83. And hopefully you guys got a z-score of 0.69. So what this is saying is the value of 68 is 0.69 standard deviations above. Okay, because if it's above, because it's bigger than, right? It's positive as well. You can check if it's positive. Now if you do the same thing for the other side where x is 72, hopefully you got a z-score of 1.37. So we say the value of 72 inches is 1.37 standard deviations above the mean of 64. So that's how we interpret the z-scores themselves. Okay. All right. So now what we're going to do is, well, how do we actually do this using, stats, right? The probability portion. So that's what we're going to be doing now. This is question 1. So question 1 says, an average light bulb manufactured by the Acme Corporation lasts 300 days with a standard deviation of 50 days. So average, so that's going to be our mu. Standard deviation, that's our sigma. Okay. And assume the light bulb is normally distributed. So this is going to be a key concept throughout this entire section and the next one as well. So whenever we talk about probability that says normally distributed, that's your hint you're going to be using z-scores to help you out. So z-scores in finding areas. Okay. So that's what we want to do. Okay. So now let's look at A. So So A says, to use the setups described in, so we're going to just cross out number 4 because we're not doing that above. So use the steps described above to find the probability that a randomly selected light bulb. So remember, probability is another word for area, right? Remember the area, probability, proportion, all mean the same thing. That a randomly selected light bulb will last at most 365 days. Now here's the question. What's this inequality look like? Is it this one or this one? Well, remember I gave you guys that little view on the section binomial probability. So you're going to have to go back and review all these because, again, like I said, going forward, you're going to have to know all those inequalities and associated ones as well. Okay, but for this one, since it's at most, it's going to be this one here because it's at most. So the largest it could be is that, but as you know, again, maximum it could be. Okay, so we're looking for the probability of x being less than or equal to 365. Okay. So what this means is, right, if our mean is 300 and here's 365, well, what are we're shading? So here's our marker. Since I want everything less than that number, I'm shading everything that's less than this. So I am looking for all of this area to be my answer. That's the answer we're looking for, right? All of this area. But like I said before, right, since, you know, this means 300, not 0, therefore we can't just look at our portion because, you know, there's no way we can actually do that. So what we're going to do is now transform it. So where our mean is 0, and now we're going to find the z-score associated with 365. So using this portion, we have the z-score of 365 minus our mean of 300 divided by the standard deviation of 50. Now we're going to find the z-score associated with that. So we'll just plug in the calculator. So again, just subtracting on top first. Should give you a z-score of 1.30. Okay, so if we get a 1.30, now therefore, if we go back over here, here's 1.30, and the good thing is the answer is still going to be the same. Since I shaded everything on the left, I am also going to shade everything on the left here. So we're going to find the area to the left of the z-score of 1.30, and that's going to be our answer for this question. All right, so in that case, therefore, we got to go take out our formula sheet. Let me take mine out. Okay. All right, so we have positive 1.30. So first two numbers is a positive 1.3. Last number is a 0. So our area is going to be 0.9032. So to write this as an interpretation, we can say the probability that a light bulb will last at most 365 days is 0.9032. All right, so let's try part B now. Keep going from this. You guys get the hang of it. So the question is, what is the probability that an acme light bulb will last at least 14 months? Assume 1 month is 30 days. So be careful, right? It says 14 months, and our mean is in days, right? So that's why they gave us a portion. So we got to first figure out how many days 14 months have. So that's 14 times 30 gives us 440 days. This is 440 days. So now, at least. Well, this one's the at most. This one must be the at least, right? So we want the probability of x being greater than or equal to 420 days. Okay. All right, so now, so if we do the same thing, this is 300, this is 420, and I want everything greater than that. So I'm actually going to shade this little sliver over here, right? So I want area to the right of the curve. So area to the right of the curve. So first thing we got to do is convert it to a z-score, right, using our formula. So z is going to equal to 420 minus 300 divided by 50. And let's see what z-score we get there. So you should get 2.40. And again, I want everything on the right-hand side. So if you guys remember, we cannot find error to the right using a z-score formula. You can only find error to the left of it. So there's a little extra step first. So first we got to find error to the left of 2.44. So again, just going back to our formula sheet, which should be right here. So it's 0.9918. And since I want the shaded region, right, not shaded, it's going to be 1 minus 0.9918, which gives you a ground total of 0.0082. Okay. So the probability that a light bulb will last 14 months is 0.0082. Really, really small chance of actually happening, right, when it comes to it. Right, so that's the first video. Stay tuned for this next one.